So we talked about the structure of enzymes, but now it's time to get a little bit more advanced with this and talk about substrate fit. And what I mean by substrate fit is its ability to fit at the active site of an enzyme. And this is based on two things. The first is its shape, the shape of the substrate, and the second is the charges involved. So we're going to walk through these individually. So let's start with shape. You all will not have to draw this because we've already drawn something like this several times. But basically what I'm doing here is putting in two enzymes with substrates that look as though they will fit like a puzzle piece into the enzyme. And that's exactly what happens. I labeled my enzyme with E and my substrates with S. One thing that's really important for us to note, it does not have to be an exact fit for the enzyme to function. So here I'm drawing a very squiggly looking active site for my enzyme, but I'm keeping the substrate the same. That nice neat triangle. And here I'm showing you how that substrate will come into the enzyme's active site. And what happens here is that the active site then molds to the substrate. It changes its conformation, another word for shape, so the enzyme changes its shape to mold to the substrate. So if we had a giant square, yes, that would not fit. However, this enzyme is able to mold to the triangle that we have. And this is what we call induced fit. This contrasts the old model that we used to think was the right one, and that was a lock and key model. We now say that we agree with an induced fit model. So now we're going to talk about the second component here. And remember, the second component of substrate fit was charge. So what I'm drawing here is an enzyme and a substrate. And the substrate goes on its business in the cell. There's a lot of random molecular motion. And maybe it hits the enzyme, but then it will probably keep going on its merry way. Things in the cell are constantly in motion, nothing static. So we can hit the active site without sticking to it. So that's where charge comes in. Because the charge differences allow for the enzyme to hold on to the substrate. And remember that this occurs at the enzyme's active site. And when I'm saying charge differences, what I mean by that is opposite charges, because remember we said that opposites attract. So I'm going to draw a very simplified version of this enzyme and the substrate, and I'm going to put charges on it. So at the top of the substrate, I'm going to have all positive charges, and then at the bottom, I'm going to say positive, negative, positive. And then there's going to be the opposite charges on the enzyme, so negatives on the top, and then negative, positive, negative on the bottom. So now random molecular motion is happening, and this enzyme is just sitting there. This substrate makes contact, but now because of the opposite charges, it's going to be stuck in there. And I know you guys can't animate it like I just did, so what you can do is just draw that arrow in. And the result that we get is this substrate stuck in this enzyme with the opposite charges attracting. So now that enzyme in the active site is able to hold on to that substrate. And because the charges are so strong and that enzyme really wants to be connected to the opposite charges of the substrate, we can say that the charge differences allow for induced fit to take place.